Hey there! Today we're diving into a common problem that arises when working with x86-64 architecture and attempting to optimize vector addition functions using SSE and AVX instructions. The problem we encountered revolves around the compiler not automatically generating vectorized code, even with optimization flags enabled. This was quite unexpected, especially given the power of modern processors and the capabilities of SIMD instructions like SSE and AVX. It's like having a sports car, but only using it for grocery shopping. Let's figure out why this might be happening. Now, let's delve into the solution that can help overcome this issue. The key lies in addressing the problem of aliasing, where the compiler struggles to determine whether memory regions like the arrays A, B, and C can overlap. To tackle this, we employ the restrict keyword, which helps the compiler understand that these memory regions are distinct and do not overlap. By using the restrict keyword in the function signature, we guide the compiler towards generating efficient SIMD code for vectorized operations, ensuring optimal performance. It's like giving the compiler a map to navigate through the memory regions without getting lost. In conclusion, by incorporating the restrict keyword into the function parameters, we enable the compiler to leverage the full potential of SIMD instructions like SSE and AVX, optimizing the vector addition function for peak performance. So, next time you're looking to boost efficiency in your code, remember to consider aliasing and the restrict keyword. I hope you found this journey into vectorization and compiler optimizations enlightening. Don't forget to like, subscribe, and drop a comment below. Happy coding!